Good morning. Am I audible? Okay, in last class, we discussed about DFA and also check some examples how to construct DFA. Today we will also see some more examples. Then I will also give some homework to you guys. Then we will see the theory part of NLP. Can you so first let's see example. Address the example. Let's see. We want to construct a DFA with symbols 1 and 0 and all strings ending with 1, 0, 0. So we have to construct a DFA with all strings ending with 1, 0, and 0. So, what is our normal approach? What can be the possible strings for the language ending with 0? That means 100 is the minimum one, 100. Apart from that, we can have 0, 100 ending with this. We can also have 1, 1, 100 repeat ending with 0. We can have multiple number of 0, multiple number of 1s, then 100. Again, we can have 10, 10, 10, any combination, just that ending should be with 100. Right. So how will you proceed with that? Remember, always start from the minimum string. If your string should end with 0, so with the minimum string for the initial state, you just take 1 and move to one state. Right? Then you take another alphabet 0, move to another state. Then you take another symbol 0 and move to the next step, which will be our final state. Right? So this is the string ending with 100. Correct? So one part is kind of done. Now you know there can be multiple number of zeros, multiple number of ones, any combinations of 1 and 0. Anything. Just that ending should be 1, 0, 0. Okay. Since there can be multiple number of 0 in front, I can put a self loop here and put 0. Right? From 0. By taking 1, it goes to state 1. Now 0 is still there, right? And our string can also start with 0. is that n should be with 100. So any string starting with 0 and there can be multiple number of 0, we don't care. So we can just put a self loop here. Okay. Next from here, 0 is already done. Next, we have symbol. Now, you see if we can give a self loop here, or we can put one symbol to any other. Okay. Just imagine you are putting it here. If I put it here, what will be the expression? It will be 1, 1, 1, 0, 0. That's fine. But there can be again 0, 1, 1, 0, 1, 1, okay, fine. But then if there is even a odd number of 1, that will be difficult. Okay. Similarly, here also cannot put because if I put it here, the string can also end with 0, 1, 1, 0. So n will be 1, 1, 0 if I put it here. This is not possible. Similarly, I cannot put it here also because directly it will go to the final state. So better I just put a self loop here, 1 and so any string may be multiple number of 0, 1, 1, multiple number of 1 and 0, 0. Okay, any string, it will end with 1, 0, 0. Right? If I give the self loop here, we don't care how many ones are in front. Okay, n will be always 1, 0, 0. Right? Now you see the next possibility for Q. Remember, for every state, you take one input symbol and go to the next step. Right? So for Q0 and Q1, both symbols are done. 0, 1 done, 1 and 0 done. Q2, 0 is done, but 1 is still left. Now, think whether you can give a self loop here. Can you put self loop here? If I give self loop 1, what will be the strings? You can, it will also accept like 0, 1, 0, which is not ending with 1, 0, 0. But if I put a 1 self loop here, then the strings won't be ending with 1, 0, 0. So I cannot put a self loop. Okay, I cannot put a self loop here. Now let's say if I take 1 here, is it okay? If all strings will end with 100, 1, 0, 1, 0, 0. So yes, if I make this transition to Q1 again, it will again end with 1, 0, 0 only. You accept string 1, then 0, then 1 to come to this step, then 0 and 0. This is the final state. So yes, this one is the correct one. Okay. You can also check whether we can put it here. If I put 1 here, is all strings will be accepted. 1, 0, 1. Again, multiple times of 1, 0, 0. Yeah, that seems okay. But again, if there is an even or odd number of things, okay, it will accept how many ones here? 1, 0, again 1, 0, 1, 1, 0. Then it will be a problem. Some strings won't be accepted. Okay, so this step, if you are in this step, if you put it back here again, then it will be a problem. Some of the strings won't be accepted. So simply I'll put it just here. Okay. 1, 0, 0. Okay, for Q2 done. Now we have Q3. Can we put self loop 0 and 1 here? We cannot. Why? If we put a self loop of 0 and 1, then it will be combination of any 0 or 1 or anything. The string will be end with 100. Therefore, we cannot put a self loop here. Now, we have two options. We have a transition state for 0, and we also need a transition state for 1. Okay. So, for example, if I put a 1 here, for example, I put a 1 here, will it be accepted? No. 1, 0, 0, again 1, 0. Possible it will end with only 1, 0, not 1, 1, 0. So I cannot put this loop here. Next, can I put it here? Put it here. Will end with 1, 0, 0, 1, 1, 0, 0. Yes, we can. We can make a transition from Q3 with alphabet 1 to Q1. Then again, all strings will end with 1, 0, 0. Okay, 1, 0, 0. From here, you come back to 1 again, then 0, 0. Same concept with this one. If you are in Q2, you are reading 1, then 0, 0. From here also, you are reading 1, 0, 0. So, all strings ending with 1, 0, and 0. Now we have 0. 0 transition. So, where to put 0 now? Can we put 0 here? 1, 0. Again 0, 0, 0. No, there can be multiple number of 0, so we cannot put the transition here. So can from here, it's already here. Can we put 0 here again? No. Why no? Because it's a deterministic. From one state, if you are taking one input symbol, it should go to different state, not to the same state. So from Q3, you cannot use both symbols and come to just one state. So what's the next? Here we can put 0 here. Now if our string is 1, 0, 0, then after taking 0, it can again end with 1, 0, 0. So this is our DFA with strings ending with 1, 0, 0. This is the final one. You can draw arrows anywhere, up, down, doesn't matter. So what we did here, string ending with 1, 0, 0. That means minimum string 1, 0, 0, accept a string, right? And there can be any combinations of 0, any combinations of 1, any combinations of 1, 0, numbers of zeros, numbers of 1. Just that ending should be 1, 0, 0. So for that, if I keep several of 0 here, doesn't matter. It will always end with 1, 0, 0. From this step, I put a set loop here. So again, doesn't matter what is the front part, the end will always end with 1, 0, 0. If you are in Q2 step, After reading 1, you will come at Q1, then again 0, 0. So again from Q2 also, doesn't matter what is the string, front the n will be always 1, 0, 0. Okay. Now from Q3 also, same thing. If I come to Q1, again it will end with 1, 0, 0. And from here, I just put it 0 here because again it will end with 1, 0, 0. Just while making the DFA, make sure the n will always be like 1, 0, 0. Any state you start from. This is about your practice. The more you do, the more it will be easier. If I make DFA starting with one, then let's see 101 again the language can be 101, then 101, any number of things, then 101, 0, 0, any number of zeros, 101, any combination of 0, 1, anything, right? So we will always start from the minimum. So from Q naught, initial state, you are reading alphabet 1, transit to the next state, Q2, then you again with alphabet 0, transit to the next state, Q3, again take 1 and transit to the final state, Q4. So in this way, it is satisfying that string is starting with 101. Right? Now again, same thing. There can be any number of zeros or any number of ones, any combinations of 0 and 1 behind. Okay, not starting. So I can put a self loop here 0 and 1. So any language or any something after 101 will be accepted. Any number of zeros, any number of ones, any combinations of 0, 1 or 1, 0. Correct? So in this way, our DFA is done. It will always start with 1, 0, 1. It will reach the final state. Again, even if it is not the final state, there are any number of 0 and 1 or any combination of 0 and 1. With this self loop, the thing will be satisfied. But is this complete? This is not complete. Right? Why not complete from Q0, 2 and 3? From these three states, we haven't considered the other symbols. From Q0, I'm going to 1, but the symbol 0 is still left. Right? So if I make a step Q5 and I put 0 here, this will be a dead state. Right? It will always accept string starting with 101 and will reach the final state. This is not a final state. This is a dead state. So any string which will start with 0 or anything other than 101, it will not reach the final state. It will just come to the dead state. Okay. So whatever symbols left, I can just connect it here. Right? So any symbols, I can connect it to the final dead state. String starting with 0 will not reach the final state. Okay. Then again, any string 1, 1, it will be not accepted. Again, from 1, 0, 0, it won't be accepted. Our main is starting with 101. After that, whatever it is, we don't care. With this self loop, it is done. But since it is not complete, we have to make sure for every symbol it goes to a next step. Therefore, whatever leftover symbols are there, you can just transit to a death state. Okay, or here you can make a 7 and it is done. So if you see, it is easier to construct DFA when like starting symbol is given. Right? But it is like if you end with something, some particular substring, then it is a bit difficult, means you have to see the other combinations. This is not and this is ending with one substring. Okay. So now see another example, simple one. DFA with odd number of 1. Okay, now I'm not saying whether the string should start with 0 or start with 1, what should be the substring and all. I'm just saying DFA with odd numbers of 1. So it can be anything. It might have only one. Language can be with only 1. It can be 1 0. It can be 1 1 1. It can be 1 0 1 1. It can be 1 1. So, but not even number of 1. 1 1 0 not possible. 1 1 not possible. 0 1 0 1 not possible. Anything, only odd numbers of 1 should be there in the substrings. Okay. So let's take a simple initial state. We'll always need to start from the initial state. What's the minimum string? 1. 1 is a odd number. So after taking reading 1, we go to the final state. Okay. Single one. Right. Now we might have even odd numbers of 1. Okay. So if I need 1 here, so won't be the odd number 1, 2, 3. After reading 3 times, it will come to the final state. Now again, if you want 5 times, then 1, 2, 3, 4, 5. Right? You want 7, 1, 2, 3, 4, 5, 6, 7. So with this loop, the odd number thing is done. Whatever you do, whatever combinations of string is there, there will be always odd number of 1 here. Okay. Now leftover thing is 0. So if I put a self loop 0, right? Initially there can be multiple number of zeros, we don't care. Then here also I can 0. Again, any number of zeros doesn't matter. So with this, you can have any number of 0 in front. You can have any combinations of 0 in the end. You can have any combination of 1 0 0 1 thing. Just that the number of 1 will always be odd. So this is the final DFA with odd numbers of 1. Let's see if this one is accepted. 1, 1, 1, yes, correct. And 1 0 1 1. 1, 0, 1, and 1. This one is also corrected. Then 5 times, this one is definitely accepted. Then let's see 0, 1, 0. The numbers 0, 1, 0, 1, 1, 0, 0. This one is also accept. So whatever you do, whatever is the combination, this will only accept all the strings with odd numbers of 1. Okay. You can try even number of ones by yourself. Okay. You try even numbers of 1 at home. That's your homework. चलेगा कैसे भी क्लास करो. Okay, so I've shown you the odd numbers of 1. Now you must try with even numbers of 1. That means minimum should be 2, 1. Then can be 4, then can be 8 and so on. So you guys just see how you can construct DFA with even number of ones. Remember in last class, I gave you guys DFA. In last class, we did an example DFA that accepts all strings A and B starting with A and ending with B. In the last class, we did this one. Now I say you have to construct a DFA which will this one. Last class we did this one, starting with A and ending with B. Okay, now I am saying we have to construct a DFA with symbols this, not starting with A or not ending with B. Okay, now we have to construct DFA which will not start with A and not end with B. This is the opposite one. Last class we did starting with A and starting with B. Now I am saying not starting with A or not ending with B. That means two parts are there. So what can be the possible language here? Not starting with A, simply it can be BA. Not starting with A, right? Starting is B and not ending with B, and ending is A. ओके सब लोग एक साथ ही करो चलेगा टेस्ट करो. So one string is BA, correct? And what can be the other strings? In this case, single A and single B is also accepted. Why accepted? Single A means what? Not starting with A is not satisfying, but it is at least not ending with B. Again, for B is also same. It is not starting with A. It's a or part. So A, B will be accepted too in this case. Okay. So whenever you see any DFA where you need to do it like not, there is a term not means accepting not starting with A, not ending with B, or not with the substring and all. You do the opposite thing. Okay? You do the opposite thing, then you do the complement. What is the complement thing? What happens in a complement? If I do C and then write a complement, the opposite thing will be there, right? If there is a plus symbol, when I do the complement, can be a negative, right? So here you can just apply the De Morgan's theorem. Whenever you see something with the not, okay, but the not is there, you can apply the De Morgan's theorem. So what happens here in De Morgan, if you guys remember, A union B complement will be A's complement or B's complement. So in simple way, now how we can construct a complement of DFA? Means we can construct a DFA which will start with A and end with A, then we can just complement it. Right? Anything with not will be the opposite of with. Okay, so what you have to do, you can just construct the DFA which will accept the string starting with A and accept the string ending with B. Okay, that is the normal way. After that, how you will complement the DFA? You have to just convert all the final state into non-final state. And the vice versa. That means all non-final state you convert to the final state. Okay, we just do the opposite. So let's construct a DFA which will start with A and end with A. If start with A and end with A, then simplest string will be AB, correct? So start with A and end with B will be simply this one. Anything starting with B will not be accepted, so I'll put it in the that state. Right? Yeah. Now anything from here, again it's the same thing. It will start with A and B. Then here I can give a self loop. So any number of B's will be okay. And I can put a loop here. So it will again start with A and end with B. So this is the DFA starting with A and ending with B. Okay, this is the normal one starting with A and ending with B. Now our question is not starting with A or not ending with B. That means any one condition needs to be satisfied. Okay, but here we need to satisfy both. It should start with A and it should end with B. But here it should not start with A or it should not end with B. Okay, so as I mentioned earlier, to complement the DFA, you just need to convert all the final state into non-final and vice versa. That means DFA not starting with A, what you have to make all non-final into final and final to non-final. That means this Q naught will become final state. This Q1 will become a final state and this Q2 will become a non-final state. Okay, and this Q3 will also become a final state. Okay, rest just keep it same. Just keep it same. This is the simplest way to construct anything with number. Okay. You can directly start with the conditions like not starting with A, not starting B, but it might be a bit complicated. Okay, this is a simple something like cheat code you can say. First make something with positive, then you make the complement. Okay, so this is starting with A and ending with B. So this is the final DFA, not starting with A or not ending with D. So B. Okay, now you see. So is it accepting A? Yes. After reading A, it is going to the final state. Is it accepting B? Yes. After reading B, it is going to a final state. Is it accepting BA or AB? Is it accepting A and B? No. Reading A and B. This is not a final state. So it is rejecting it, which is the thing we want. It is not starting with A and not starting with B. After reading AB, it is not going to the final state. So it will again read A, then B. Okay. So next, and again it will be in B and so on. So simplest way to do anything with not is that you make the straight one, then you make the complement. Okay. So you can try DFA not containing 110. Okay. I'm saying containing 110, not containing 110. Okay, this is again a. So what you have to do first, simply construct a DFA containing 110. Remember, this is just containing. It's not starting or not ending any string. Just that this one will be a substring. Okay, the language can be like obviously 110 will be the minimum one. Then the normal. So first you check the containing one, right? If containing 110 means 1, this is the simplest one or the shortest substring, then it can be 0, 1, 1, 0. You can write 1, 0, 1, 0, 1, 1, 0, and so on. This is with containing. So first make the DFA which will contain 110, then you make the complement. How you make complement? Make final state into non-final and non-final to final. Okay, you can also try with simple logics like how we construct DFA which will contain 110 with simple logic, right? Means what will be the next move if I move to this, what will be the possible combination if I move to next step. Okay, but the simplest way to do anything with like this is this. Okay, so first make a DFA which will contain string 110, then you make the complement and it will be a not containing 110. Obviously string is 10. Okay, so homework 1, this, and homework, this one. Even number of these two. DFA with even number of 1 and DFA string not containing one answer. Okay. खुद ट्राई करो नहीं तो समझ में नहीं आया. Okay, this meeting is going to stop sharing. Tomorrow we will see NFA. I hope everyone is using your copy and pen. Without that, you will be super confused and you won't understand anything.